Good morning everyone. Today we are going to see a new topic, riveted joints. So in previous lecture we have seen columns and their connections, how it is going to failure, whether it is in a crushing failure or a buckling failure we have seen. So today we are going to see about the joints, that is how we are going to connect two beams or two columns or two plates, two steel plates. So here we are going to connect using two types. One is called as rivet, another one is weld. So currently in this lecture we are going to see about the riveted joint. So you can see here that riveted joint is typically for joining two or more plates which have been used in the used as a stud or used as a column or used as a beam, whatever the structure it may be. Then types of riveted joints. One is lap joint, another one is called as butt joint. So this is a typical lap joint. So what is lap joint? This is one of the main plate and this is another one main plate. So it is placed one over the other and a rivet is being joined. So rivet is nothing but it is similar to a bolt nut. It is similar to a bolt and nut. But it is a simple, it will not have a bolt, but it will have a nut and you will seal in on the other side. So this is called as a rivet. So lap joint is nothing but keeping two plates one over the other and then joining. It is called as lap joint. So here if it is one rivet, it is called as a single riveted lap joint. If two rivets, it is double riveted. If it have three rivets, it will have triple riveted joints, etc. Then next is called as a butt joint. Butt joint is nothing but, you can see here, this is a diagram for a butt joint. Two main plates are kept aside. This is a separation point. It is kept near and near, and another connection plate is placed at the top, and then two rivets are joined. It is called as a single cover plate because only one cover plate is available. If it has two cover plates in the up top and the bottom, it is called as double cover plate. So these are the types of butt joint. So this type of joint is called as butt joint. If you can see here, if two members are kept overlapping, then it is called as lapping joint. Okay, then based on the orientation of the rivets, it has been classified into three types: chain riveted, zigzag riveted and diamond riveted. So chain is nothing but keeping the rivets in horizontal and vertical position. It is called as chain rivet. If it is arranged in a zigzag manner, then it is called a zigzag riveted joint. Then if a number of rivets are higher value, then it will be shaped like a diamond. So it is called as diamond riveted joint. So let's see with a typical top view and elevation view of all the types of joints. So first one here is single riveted lap joint. So this is called a single riveted lap joint. You can see two plates are placed one over the other. So this is plate 1 and this plate 2. So this is the plan or a top view of the plate, and this is the front or elevation view of the plate. You can see, that is, we are going to see in this direction. We are going to cut exactly at the middle here and you are going to see in this direction. So you can see that one plate is placed above and the second plate is placed below, and these two are connected by a diameter D, and the diameter of the rivet is capital D. And you can ask that why it is single riveted joint. Here you can see that three rivets. What is single riveted exactly means, when you see in the front view, if there is only one row, then it is called as a single. If you see in the front side, if you have two rows, then it is called double riveted. If it extends to three, it is called as three riveted. So you can see that in the front side, you can see only one rivet. Then you can see that the center of the rivet to center of the rivet, this distance is called as pitch of the rivet. Then what is the distance? The overlapping distance. How much distance it may be? It should be from the center of the rivet 1.5 times the diameter of the rivet, and here 1.5 times the diameter of the rivet. It should be overall, it should be overlapped by 3 times of diameter of the rivet. So similarly here for the double rivet, So 1.5D and this side 1.5D. At the center it is 2D plus 6. 2D plus 6. That is D is nothing but diameter of the rivet. And then in this diagram you can see this is the pitch, and this distance, that is horizontal distance, is nothing but it is called as gauge distance. Gauge distance. Then this is called as diagonal pitch. Okay. So next, this is the diagram for double riveted joint. Double riveted lap joint with zigzag riveting. You can see that it is zigzagly arranged. So here if you cut here the position, and if you see that this here there is no rivet at all, so it should be in a shaded portion. Here the rivet has been cut into two halves, so it is seen as white here. So in this case, in zigzag, the only difference is the center distance. The center distance can be reduced as 2D. In previous thing, you can see that it is 2D plus 6. But here it is only 2D, there is no 6 at all, because it is in a zigzag manner. So here also the same distance between the two rivet joints is called as pitch, and this is called as diagonal pitch. So next one we are going to see about butt joints, diagrams of butt joint. So this is single cover butt joint. You can see the top connection plate. So this is the plate 1, and this is plate 2, and this is the cover plate or connection plate. Over the connection plate you have here 6 rivets, and in the front view you can see 2 rivets. It is the metal plates. The main plates are kept aside each other, and one single cover is placed over it, and it is riveted. So the distance is now for the butt joint it is 3 times the diameter. It is 3 times the diameter, and here 1.5 times diameter and 1.5 diameter. Then for a double cover, so double cover you will have 2 cover plates. 2 cover plates. You can assume that here the thickness of the cover plate is T, and here it can be T by 2. It can be T by 2. So this is a total diameter. So 1.5 diameter is 3 times the diameter, 1.5 diameter. This is a typical diagram for a double cover single riveted joint. Then this is multiple, that is double covered with 2 riveted joints. For butt joint, we have to see at only one side. So if it has 2 on one side, it is called as double riveted butt joint. So here also you can see that the distance is 2 times D, and this center is 3 times D, here 2 times D and 1.5 times D. So this is a typical diagram for a double riveted butt joint. Okay, now we have seen as what are all the types of joints in the rivet and how the orientations are there. So next is we have 2 objectives in this thing. One is to find the force for a given rivet, or to find out this, and then or to find the strength of the rivet. The another objective is to find or design the number of bolts required for a given load. So these are the 2 types of things you are going to see. One is for a given number of bolts, what will be the force, and for the given force you have to design how much number of bolts or rivets. Here you can see that failure. So first case we are going to apply what is the force available for a given number of rivets. Here first one is failure due to tearing of the plate between the rivet holes and edge of the plate. We can clearly see that there is one rivet here. This is one plate and this is second plate. It has been pulled this side and this side. So a center rivet can be break at this edge. So this is the edge of one plate, and you can see this distance is m, that is small m. As per the diagram, it should be greater than or equal to 1.5 diameter. M should be greater than or equal to 1.5 diameter. If it is much lesser value, then surely it will break here or it will crack here. This type of failure is called as failure due to tearing of the plates between the rivet hole and the edges. Then second one is called as failure due to tearing of the plate between the rivet of the row. between the rivet of the row. You can see here 3 rivets are attached. It is a lap joint. You can see that clearly the crack forming exactly on the diameter, exactly on the rivet. Here if you remove the rivet, it will be seen as a hole here. So this is the minimum cross section area available for the rivet. You can see here the formula here, the safe load is safe tensile stress into area of the plate per pitch length. Area of the plate per pitch length into safe stress. So stress is available as sigma T. So for each type of plate, if it is a steel plate, it will have a specific stress value, that is failing stress value. So and then we have to find the area of the plate per pitch length. What is pitch here? Center to center distance. Pitch is called as center to center distance. Then how come it will be area? So you have the thickness of this particular plate. You will have thickness of the particular plate. So multiplying the pitch distance and subtracting the whole area. You can see from center to center it is pitch. From center to center. But it is a hole, cut area. Then you have to reduce the radius of here and radius here. So subtracting 2 times the radius, that is you have to subtract 1 diameter. So total pitch distance P minus 1 diameter, here 1 radius, here 1 radius. So 2 times radius subtracting 1 diameter. So this is the length available of the plate, and then into the thickness of the plate, that is called as area of the plate per pitch length. So multiplying by the stress, you will get the P value. By multiplying by the stress, you will get P value. So this is the safe load available for a number of bolts. So this is failure due to bolt hole available here. Then failure due to shearing of the rivet. What is shearing? It is called as a cutting. If you pull this plate and this plate, at the junction the rivet might get cut into half. The rivet might cut into half. This is for a lap joint. And this is for another type of lap joint. It have 2 plates one over the other and the center middle. You can see that here there is one cut and here there is one cut. 2 areas have been cut. Okay, so this is called as shearing failure. For this, how to adjust? So we have to find this area. What area? The rivet area. So you can typically see in the plan that this is the area of the rivet. This circle is the area of the rivet and diameter of the rivet will be given. So now our area is nothing but pi by 4 into d square, pi by 4 into d square. So in this case, 2 areas have been cut. So 2 times the area. So here it is 1 area, here it is 1 area and 1 area. Here it is shows 2 areas and here 1, 2, 3, 4. It is 4 times the area. You can typically see the formula is safe load is this is for single lap joint. Only 1 area is available. So 1 into that area into the corresponding shear stress, that will be safe load. Here it is called as shearing failure. So shear stress must be applied. That is area into shear stress. Then in case here it is 2 areas. So therefore it is 2 here. Then here it has okay, you can see here 1 area, here it is 2 area, and if it is triple riveted lap joint, which means that you will have 3 rivets, then 3 times the area into 5 into sigma. So this is a safe load. So similarly for butt joint, you can see for this is one single riveted butt joint. So you will have one joint. So 1 into 2. If it is double riveted, you have 2 rivets on one side, then 2 into area. For butt joint, you have to see only one side, not on both sides. So here it will have 1, and for the double riveted you will have 2, and for the triple riveted you will have 3. So this is the typical thing. Then safe load pitch length for the case of butt joint. with a double cover. So for double cover, if it is a single riveted, you can see here it is 2 area, that is 1 and 2. So for single riveted itself, it will have 2 times. So you will have 1, 2, 3, 4. There is 4 areas. So if it has n number of pitch length, then you will multiply n times. That is here, if it has 1, 2, 3, etc. up to n number of rivets, then n into 2 into pi by 4 d square into tau. So this is for number of pitch length, where n is the number of rivets covered per pitch length on one side of the joint for the butt joint. So n into pi by 4, you can see that for butt joint you have to multiply by 2, because it will have 2 areas. For cover plate it will have 2 areas. If it is a single cover, then you will have only 1 area. So this is a shearing failure. Then failure due to crushing or rivet of the plate. In one of the plates, you can see that the bolt is available here. If the plate is weaker than the rivet, then you can find out there will be some this is called as bearing or crushing failure of the plate. Bearing or crushing failure of the plate. The rivet will not happen, it will be strong enough, but the plate will start to deflect, or it will start to break. You can see that the formula is n into sigma c into d into t. So here the d is nothing but diameter of the rivet, and sigma c is allowable crushing stress, and p is safe load. Here sigma c into projected area. What is projected area? You can see that this is the projected area. So diameter into thickness. If you see in this side, front side, so this is the area. So this is the length, diameter into thickness of the plate. So that will be the projected area. You can see that sigma c into d into t. If there are n number of bolts, so n into sigma c into d into t. So this formula will be available for which one? Bearing or crushing of the rivet or plate. So these are the types of failures. We can see that there are 4 types of failures here. And finally, failure due to crushing of the plate. So you can see the final thing is crushing of the plate, which is nothing but sigma into p minus d into t. So it is called as, so crushing of plate is nothing but you have to find out the direct plate, that is sigma t into the width of the plate into thickness of the plate. It is called as final crushing of the plate. Then how to find out the strength of a riveted joint? Strength of the riveted joint. So you have seen here there are 5 types of failures. You have to find out the p value for each failures, and you have to find out which is the least one. That is called as strength of the riveted joint. Again I am saying you have to calculate all the 5 safe load, on each conditions, and you have to select the least one, the minimum value of p. That will be the strength of the riveted joint. You can see this is each one of the plate. So one is for normal, this is for the first case, and this is for the second case, that is shearing, the third case for the stress. So we have to find out all this and find the least value. So nothing but it is a maximum force which the rivet can be transmitting without failure, which means the minimum value of these 5 p values. So it is called as strength of the joint. Then what is the efficiency of the joint? It is nothing but strength of the riveted joint divided by strength of the solid plate. Strength of the riveted joint divided by strength of the solid plate. That is least of the p value and the given p value. So it is nothing but sigma c into p into t. Sigma t into pitch distance into T. So this is called as strength of the solid plate. So these are the formulas you have to remember. These are the formulas you have to remember. So using this, we are going to solve some of the problem. We will see in the next video. Thank you.